Welcome student to the Lagrange multiplier. In this example, we want to use the Lagrange multiplier method to find the maximum and minimum value for this function x(ex) subject to a given constraint where x squared plus y squared equal 2. So since we're given a constraint, which is an equation between x and y, usually we call this g of xy, here we have to use Lagrange multiplier. And to use Lagrange multiplier, we need to solve a system of equations. What is the system of equations? The first one, we need to find fx, and we make it equal to lambda g of x. This is the first equation. Second equation is fy equal lambda g of y. And the third equation that we will use is we keep g of x, which is the constraint, exactly as is. So the first equation will give me the following. So if I need to find fx, this will be, I'm sorry, I think there's a typo here. This is g of y. If I need to find fx, it will be just ex equal lambda. And then we need to find gx, which is only 2x. This is equation number 1. Equation number 2, if we need to find fy, this will be xey, because the derivative of ey is exactly only ey, and x, we consider it as a constant. Then we have lambda, and then we have g of y, which is 2y. And this is equation number 2. Equation number 3, which is again important one. Equation number 3 will be just the constraint itself. So x squared, y squared equal to 2. And this is, we consider it as equation number 3. Now, we have a system of 3 equations, and we have 3 unknown. Now, usually when we have a system like this, things are a little bit easier because we have 3 equations, 3 unknown. Maybe we can find the value for x, y, and lambda. So we have to play with those 3 equations. And the first suggestion that came to my mind is, what if we substitute, sorry, this is ey. What if we substitute from equation 1 ey, we take this ey, and we substitute it here. So instead of this ey, I will put lambda 2x. That will help me at least move from y into an equation with lambda and x. So substitute equation number 1 into equation number 2. Let's see what we get if we do so. We get x, this is from equation number 1. This will be lambda 2x. And the other side will be just lambda 2y. Now let's see what can we get here. First of all, we can see that there is a clear cancellation, 2 and 2. On the left side, we have lambda x squared. On the right side, we have lambda y. Now, again, please do not divide by, for example, lambda. It's temptation to cancel lambda, but what if lambda equal to 0? We cannot divide by 0, and of course in this question there is no hint for me that lambda will never be 0. So if you want to divide by lambda, you have to ensure that lambda is not 0, which is we don't have that assumption. So the best idea is we do the following. Take everything to the other side, we get lambda squared minus lambda y equal to 0, and now what you need to do is take lambda as common factor. That will be much cleaner here. So just let me go to the next page. So if I take lambda as common factor, what I will end up is x squared minus y equal to 0. Now we have 2 numbers. If we multiply them together, we get 0. So we have 2 options here. Option number 1, lambda is either it's equal to 0, or we have x squared minus y is equal to 0. So we have 2 branches, 2 options. We need to follow each one separately, lambda equal to 0, we need to find x, y if we can. Here, we need to find x, y, and lambda. So each one kind of a different question by itself. So let's go back now and let's focus on what happened if lambda equal to 0. So we go back to our three famous equation here. Now what happened if we substitute lambda equal to 0, for example, in equation 1 or maybe in equation 2? I will substitute in equation number 1. So back to equation number 1. Or let's say substitute lambda equal to 0 into equation number 1. Substitute lambda equal to 0 into equation number 1. What do we get? We get ey to the left equal 0 to the right. That's what we get here. If we go back to the equation, if we put 0 here, everything here would be just 0, so ey equal to 0. Now, ey equal to 0, this has no solution. Why it has no solution? Because remember, if it has a solution, what you will end up doing is you will take ln for both sides. So if you take ln for both sides, just let me do it here quickly. Ln here and ln here, this is undefined. We don't have ln 0. So it has no solution. The exponential function never equal to 0. So this has no solution. This means I will never find x or y. This means this branch has to be disregarded. So this option is disregarded. Which means we left up with only one option, which is option number 2, that x squared minus y equal to 0. Now, in this option, I will get that y will be directly equal to x squared. Now, if I go back to the three equations that I have before, equation number 3 is the only equation that has only x and y. So what happened if I substitute one of the variable into the other? So here, what I will do, substitute x squared equal to y, which is this equation, into equation number 3. Now, equation number 3, it was x squared plus y squared equal to 2. That means if we substitute x squared and we write it y, this we get y plus y squared equal to 2. So this is x squared, this is y. Finally, we get y squared plus y minus 2 equal to 0. Now, if we solve this equation, here we will have two numbers that we can get. If we solve this equation, y equal to 1 or y equal to minus 2. And in each equation, we have to find the value for x. So this is a different branch continuing in the same direction. Now, if y equal to 1, we know that y is the same as x squared. That means we have two values for x, which is either x equal to 1 or x equal to minus 1. So far, so good. We have a very good news that we can find the value for x and y. So we find value for y, and here we have the value for x. The only values that we need is to find the values for lambda, and that's what we will do next. But before that, let me go and deal with this side here. In this side, I will have x squared equal to minus 2, which again has no solution. So this branch or this option is disregarded. Now, what we end up with is y equal to 1, x equal to 1. So here we have to find lambda. How do we find lambda if we have x and y? We go back to the three equations. I don't know, we can use, for example, this equation. If we put x equal to 1 and lambda equal to 1, here we will get that lambda equal e over 2. And in this case, here we have lambda equal negative e over 2. So we get the values for the lambda by substituting in equation number 1. So that's so far what we get here, and we find all the branches, we follow all the options, and the only answers we have is y equal 1, x equal 1, lambda e over 2, or y equal 1, x equal negative 1, lambda equal negative e over 2. The final answer is we make this table here. Where we put the value for lambda, the value for x comma y, and finally we write the value for f of x comma y, which is equal to x e y. Well, first lambda was e over 2. Second lambda was negative e over 2. This was 1 comma 1, and this was minus 1 comma 1. Now if we substitute, we get e, and this will get us negative e. Of course, where is the maximum? This will be the maximum because it's the largest, and this will be the minimum for sure, because those are the only two values that we have. So the maximum value, if we just summarize what we did, is e. The minimum value is negative e. Lagrange multiplier is those lambda, and the maximizer and minimizer are written in this table. So that's the Lagrange multiplier. Thank you for